try our code. We'll go back to our terminal, and you notice that currently we have 15 failures. Let's run our test again. And boom, we've got 14 failures now. And these 2 lines of code is exactly what we need to apply to all of our API tests. And now the question is, should we really copy and paste this to all of the test functions? The answer is a big no-no, because we'll need to repeat ourselves for an awful lot of time. There is a better way to do this, and it is through the setup and teardown testing hooks. So Laravel provides us 2 special testing methods called setup and teardown. Setup is a special function that will run just before each of the test functions is executed. And teardown, on the other hand, will run after each of the test functions is executed. So in our case here, we want to log the user in before each of the test functions is executed. So let's go ahead and create the setup function. And we do need to specify the return type, otherwise our IDE will complain. Inside the function body, I'll simply move our login logic from the testIndex method to here. And now this setup method should log a user in before we run all the test functions inside this user API test class. Let's go to our terminal and we'll run our test again. And we're down to 10 failures. Beautiful. Now the next thing that we want to do is to copy and paste this code to the other test classes as well. We'll paste it in our post API test and also comment API test. Let's go back to our terminal, run our test again, and we're down to 1 error. Seems like this error is not about authentication, but we have an invalid request body when we're creating a new post. Let's quickly fix that. Our post body should be an array, not a string. So we'll go to our post controller and change the data type from string to array. We also need to include an array of user IDs, so I'll go back to our test method and quickly create a dummy user. And I'll pass the user ID as part of the request body. Since body is a required field, we will also go to our post factory and put in some random value inside the body field. Let's go back to our terminal and run our test again. And it's now all green. Great! Now before we end the lesson, I want to show you how teardown looks like. As I mentioned just now, teardown will run after a test is executed. It is useful when we want to reset any side effects that we might have when we are running our test. For example, clearing out database records or deleting files that we might have created in the test. And just for demonstration, I'll dump a random string in our teardown method here. Let's go back to our terminal and run our test. And we see 5 hey yes inside our terminal, because we have 5 test functions in our user API test class, and Laravel runs teardowns for 5 times. Now before we end the lesson, there's one more thing about the acting as method. It can actually take in a second argument where we can specify which login guard that we want to use. By default, it is using the web guard, but we can change it to API guard or other guards that you define inside the auth config file. And just for recap, guards are ways that we can log our user into our app. You can define as many guards as you like inside the auth config file. But for most scenarios, the default works great as it is already, so you don't need to touch them at all. And that is pretty much it. Key takeaway for this lesson: Laravel provides us a convenient acting as method to log in as any given user. The setup method is a handy special function that runs before every test function. It's good for us to put in logic where we want to apply it for every test function inside a test case. Teardown is the opposite of setup, and it runs after every test function. Acting as accepts a second argument where we can specify which auth guard that we want to use. We can add more auth guard in the auth configuration file if we wish to. That's it for this lesson, and I'll see you again in the next video. Hey there, Sam. Internationalization is the notion of providing different translation to the end users based on their local preferences. A lot of time in the internet, you'll see people referring to this as I18N. Why? Because there are 18 characters between I and N. There's another common term in the web, A11Y, which stands for accessibility. Again, because there are 11 characters between A and Y. But if you ask me, how did they come up with such weird abbreviation? I'll be honest with you, I have no idea. But I'll tell you one thing for sure, programmers are weird, and you are one of us. Anyway, enough talking. Laravel makes internationalization very easy for us. Now if you look at the resources folder, underneath it, there's a folder called lang. And this is exactly the folder where we put all the translation files. And by default, as you can see here, Laravel has already put a EN folder which stands for English, in here. And in the English folder, there are 4 built-in translation files already. Let's take a look at the auth translation file. And as you can see, it's a normal PHP file that has an array of messages that we want to display to our user in our app. So the idea of these translation files are simple. We will write our app messages in different keys. And in our app, if we want to display these messages, we simply need to reference them by using these keys. I'll show you how to reference these keys in just a minute. Practically speaking, every messages that we display to the user in our app should be a reference to one of these translation keys. So by the end of the development cycle, we should have a lot of these translation files. And to create a new locale in our app, we simply need to create a new folder in the lang directory and copy and paste all the translation files into the new language directory. And we'll pass all these files to a translator and get the translator to translate each key into the other language. Alright, now let's talk about how we can get all of these messages out from the translation files. I'll go to our web.php file to play around with the code. So there are basically 2 main ways for us to get translation keys. The first way is to use a lang facade and a get method on it. The get method accepts a key argument where we can use the dot notation to access the relevant translation key. I know the auth file contains the key called failed, so I'll just say auth.failed. So now in theory, if I dump the string here, I should get a message associated to the failed key in the auth translation file. And now if we go to our terminal and run php artisan serve, and we did see our translation message get dumped inside the terminal, while Laravel is trying to boot up the development server. By default, our app locale is in English. That's why we are seeing our English translation in our terminal now. You can change the default locale in our app configuration file. However, if for any reason you want to change the locale on demand, we can call the setLocale function on the lang facade and change it to another language. The language that we put in inside the function has to match the folder name that we put in inside the lang folder. So now if I change it to Spanish, the get function from the lang facade will attempt to read it from the ES folder in our lang directory. And now let's go back to our terminal and run php artisan serve again, and we see a Spanish translation. Now instead of using the get method on the lang facade, Laravel provides us a helper function to get translation keys. The helper function is simply a double underscores. And now if I try to use the double underscore to grab the password key and go back to our terminal, run php artisan serve again, and it still works. So the double underscore is really a short and quick way for us to get translation keys. And now if we go back to our auth translation file, you'll notice that in the throttle key, there is a placeholder called seconds. The placeholder allows us to dynamically insert data to replace the placeholder string. So to replace seconds into some numbers, what we need to do is to pass in a second argument to the get function or the double underscore function. The second argument is an array where it contains the mapping of the placeholder string against the actual value. Let's run a code. And as you can see, the translation has replaced the seconds placeholder into the numbers that we put in inside the double underscore function. Isn't that neat? Alright, let's move on. To get the current locale, we can use the app facade and call the current locale function. Let's give it a go. And we see en dump in the terminal. And now you might be asking, I thought we have set our language to be Spanish on line 33. Why is it showing en now? And you're right. The setLocale function called on the lang facade is only setting the locale on the facade level. If we want to set the locale on the application level, we should use the app facade instead. The app facade also provides us a setLocale function that works exactly as its counterpart in the lang facade. And now let's go back to our terminal and try again, and now we see ES instead of EN. Great! To check for a locale, we can call the isLocale function on the app facade. So if I pass in EN, I would expect to get a false here. Let's go to our terminal and run our code, and we do get false. So far, so good. Other than using PHP files, Laravel also allows us to use JSON files to write our translation files, but the convention is a little bit different. If we want to use JSON, we only need one single file, in contrast to the PHP files where we split the translation into multiple files. I'll show you an example now. So if I want to create a JSON for Spanish, all I need to do is to create a es.json inside the lang directory. Now the way we write translations inside a JSON file is different to the PHP files. We will map a whole sentence to a sentence, instead of just a single key to the translation. The translations provided in a JSON file is normally used as a fallback when Laravel couldn't find a corresponding translation from the PHP files. Okay, let's try out our JSON translation. So back inside web.php, if I attempt to translate "this is Sparta," and in our terminal, we see the Spanish translation that we put in inside the es.json file. Great! But now here's a big question. Which one should we use? Should we use JSON files or PHP files? And my answer is, it's up to you. Pick whichever that you think is easier for your project. However, Laravel's documentation did suggest that to use JSON if your app has a large number of translatable strings. Alright, let's move on. Let's talk about pluralization. You see, pluralization is a hard problem to solve. Each language has their own rules when it comes to making plural terms. So Laravel left this complicated task to the hands of the translator. That means if we have a translation, we should provide the singular form and also the plural form in the translation file. And now let's take a look at how this thing works. Let's go to the auth.php files and I'll create a new key called pants. For the singular form, I will say I have only one. And now to provide the plural form of this translation, we'll put in a pipe operator right after the singular translation. So the left side is singular and the right side is plural. Let's try this out. We'll go back to web.php. Since we're using English now, I'll change the locale back to en by commenting out the set locale function. And now to get a plural form of the translation, we can no longer use the get method or the double underscore function. Laravel provides us another helper function called transChoice to get the plural form of a translation. So the first argument is the key to the translation, which in our case will be auth.pants. And the second argument is the number of the item. Any number other than 1 will resolve to the plural form of this translation. So if I put in 1 for now, we would expect to get the singular form. Let's run our code, and we see I have only 1 in the terminal. And now if I change the number into anything other than 1 and go back to our terminal, and we see I have a lot of pants. And remember, by default, in order for us to get a plural form, we can put in any numbers other than 1. This includes 0 or negative numbers. I'll show you what I mean. So if I change the number to 0 and go back to our terminal, we still see I have a lot of pants. And now if I change it to a negative number, we still see I have a lot of pants. It doesn't make sense, right? So to solve this issue, Laravel allows us to write more complicated pluralization rules to fit for multiple ranges of values. Let me show you a quick example. So let's go back to the auth.php file and I'll add in a new key called apples. I want to have 3 different translation sets. When the number is less than or equal to 0, I will say there's none. When I only have 1 apple, I want to say there's only 1 apple. When I have more than 1 apple, I want to say I have many apples. So for the first set, I need a range. We can use a square bracket notation to define a range of number. So square bracket star, comma 0 means that for any numbers that is below 0, I want to say there is no apple. And same as before, I'll put in a pipe operator to define the next set. For the next rule, I want to have exactly 1 apple. So I put in a curly braces and put in a number 1 in it. And the translation is there is 1 apple. And for the third set, the range is 2 and beyond. So square bracket 2, comma, star. And the translation string is there are many apples. So far, so good. Let's try it. We'll go back to web.php and call the transChoice function again. The key is auth.apples. Let's start with negative numbers. So if I put in -1, I should see there's no apple. And in our terminal, we did see the string there is no apple. It is working. Let's try 0. And we get the same string again. What about 1? And we get there's 1 apple. Let's try 2. And we see there are many apples. Sometimes we do want to show the numbers inside our translation string. For example, I would like to show there are 2 apples instead of there are many apples. And Laravel makes this very easy for us. Let's go back to our translation file. And to show the numbers, we can use a special placeholder called count. So I'll replace the word many with count. And go back to our terminal, run our code again. And now we see there are 2 apples. Great! The third argument inside the transChoice function accepts an array of placeholder values, and it works exactly the same as the double underscore function and also the get function from the lang facade. Let's pass in a placeholder called baskets, and I'll give it a value of 2. And now let's go back to our translation file. I'll put in the basket placeholder at the very end of the string. Let's run our code, and we see there are 2 apples in 2 baskets. Alright, last thing before we end the lesson, Laravel also makes it very easy for us to capitalize the translation string. For example, if we have a welcome key in our translation file, that would greet the user. We normally want the username to be capitalized. Let's say I'm using the name placeholder as the username, so to make the first character capital case, all we need to do is to make the first letter of the placeholder capital case. And just for demonstration, if I want to make the whole word in uppercase, I'll put the placeholder in all caps. And similarly, if I want it to be in lowercase, the placeholder should be in all lowercase as well. Let's give this a run. Back to web.php, I'll use the double underscore function to get the welcome translation and pass in the name placeholder as Sam. And now let's go to our terminal and run our code. And we see Sam in 3 different casing. So far, all of the examples that I have shown you in this lesson are quite trivial and just for demonstration purposes only. In a real-world scenario, it should be roughly the same as what we have done so far. Just call the double underscore or transChoice function wherever appropriate in our Laravel app. For example, in the welcome blade file that we created in the previous lessons, instead of hard-coding the welcome message, we can use our translation string. So I'll replace the whole line with double underscore of welcome and then pass in the name variable to the name placeholder. You can do the same for the rest of the app, and I'll leave this as an exercise for you. In theory, you should use translation string for all the strings that we want to show to our end user. Okay, that's roughly everything you need to know about translation. Key takeaway for this lesson: internationalization, or I18N, is the notion of providing translation to different locale. Laravel provides us the double underscore function or the get function on the lang facade to retrieve translation from the language files that we have in our project. Laravel puts all the translation files inside the lang directory that lives inside the resources folder. We can choose to write our translation files in either PHP or JSON file format. transChoice is another helper function for us to handle pluralization. That's it for now, and I'll see you again in the next video. Hey there, it's Sam. Sometimes in our application, we just want to share a link that will expire or just send a link to a certain group of people. These features can be very useful in apps that involves resource sharing, like a cloud drive or a video sharing platform or even a private chat room. And now the big question is, how are we supposed to generate this link in Laravel? The answer is simple. Thankfully, Laravel provided us a nice to use API to generate this type of links. Let's take a look at the code right now. Let's say we are running a video sharing platform like YouTube, and we want a feature that will let our user to only share their videos with their friends and family, but not everyone in the world. Okay, first of all, let's create a fictional URL that will serve the video that the user wants to share. I'll create a get route and call it shared video and the video ID. And just for demonstration, I'll simply return the word get good, just to motivate you. And now let's go to Postman to test this route just to make sure that it works. And we see the word get good as expected. And now I want to protect this route so that only people with the special link can access this route. To do that, we can use the source code sign URL to achieve this. In programming, signing means to protect a certain things from future tampering. If we are signing a route, that means if anyone attempted to change a part of the route will no longer work and the server should refuse to accept the incoming HTTP request. If you're confused at this point, don't worry, we'll explore on how this works in the next few minutes. So to create a sign route in Laravel, we'll need the help of the URL facade. Laravel provided us 2 variants to sign a route. One is with an expiration time, which is useful to create a temporary link. The other one is just to call the sign route function, and that is helpful to create a permanent protected route. I'll go ahead and call the temporary sign route function in this demo. Now the first argument in this function is asking for a route name, which is a reference to an existing route in our app. In our case here, we want to turn our share video route here into a protected route. So let's give our route here a name. I'll call it share video. And then I'll go ahead and pass the name share video into our sign route function. The second argument is the expiration time. which is the timestamp that this route would expire. And just for demonstration, I'll only let this route to live for 30 seconds. Otherwise, this video will be a few hours long just for me to show you what will happen when the link is expired. Once we have added the expiration time, we can simply return a URL and we'll go to Postman and call our playground endpoint to see how this thing looks like. And whoops, I made a mistake here. We see an error. And if we look at the error message, it's saying that we're missing a required parameter for our share video route. Our share video route accepts a video URL parameter, so that means when we create our sign route, we should also pass in a third argument that will supply the value for the video parameter. Let's go back to Postman and try again. And this time it works. And we can see inside the response body, we see a sign URL. It is a URL pointing to the shared video endpoint, but it also contains two query parameters, expires and signature. Expire is the timestamp that this URL will expire, and signature is a unique hash that will stop people from tampering with this URL. It is the main mechanism that will protect our route from modification. Let's explore how these things works on a deeper level. So now when someone attempted to visit a signed URL, we need some sort of logic to verify the route signature. And there are two ways to do this. One is through a helper function on the request object, which is called hasValidSignature. Two is to use the sign middleware provided by Laravel out of the box. So to use the helper function on the request object, we simply need an if statement to check if the request has a valid signature or not. If not, we'll abort the request with a 401 error code. Alright, let's give this bad boy a go. We'll go back to Postman. We will send a GET request to the playground endpoint again to get a new signed URL. And I'll copy the signed URL and send a GET request to it. And we get good in the response body, which is expected because we're still within the 30 seconds limit. And now if I attempt to change the signature hash to something else, this URL is no longer working. And we see a 401 response code because we no longer have a valid signature in our URL. And if I change the signature back to the original, we still get a 401 error because we have passed the 30 seconds time limit and the URL is now expired. Let's try again. I'll get a new sign route, and this time I'll try to be cheeky and attempt to see some other videos other than the one that is currently shared to me. I'll change the video ID from 123 to 122 and hit enter, and we see a 401 error. That means we cannot view the video. Change it back to 123 and we see get good again. Can you see how the signed URL is protecting the route? We can only see the resources that was signed originally, and if we attempt to change any part of the URL, Laravel will simply not let us to pass.
You shall not pass!
So that was signed route by using the helper function on the request object. We can also apply the built-in middleware called sign to do the signature check. I recommend to use the middleware rather than the if statement because our code will be cleaner. Let's go back to Postman again. We'll get a new URL and attempt to visit video 122 again. And this time, the middleware is sending us back a 403 error with the message invalid signature. And that is all working. And now the big question is, how does this thing work behind the scene? To answer this question, we need to look at the source code. First of all, let's visit our HTTP kernel file. And if we look at our route middleware mapping, we can see that the sign middleware is mapped to a middleware called validate signature. And in the handle method of the middleware is really a wrapper around calling the hasValidSignature function on the request object. And now if we follow through the function definition, we find ourselves inside the request class. And seems like this hasValidSignature function is a magic function living elsewhere. And that means we can't see its implementation inside the request class. What should we do? That's okay, we can do a global search. We will need to search not only in our project, but also from the Laravel source folder. And looks like I have found it. It is a macro where the definition is living inside one of the Laravel's built-in service provider. We haven't talked about macro in this series before. It is one of the Laravel's feature that allows you to add functions to a class on demand. Personally, I'm not a big fan because it seems a little bit magical to me. And if you use too much of it, it'll be very hard for you to debug your code. Anyway, in here, Laravel has added the hasValidSignature function to the request class, and it is simply a wrapper around the hasValidSignature function on the URL facade. The URL facade is based on the URL generator class. Let's try to look for the hasValidSignature function inside the URL generator class. And we have found it. The function is calling two methods in it. One to confirm whether the request has a correct signature, and the other one is to make sure the signature has not expired. Let's look at the first function for now. And here we are, we have some scary code in front of us. What's going on here? So the first line is to get the whole URL, and the second line is to remove the signature query parameter from the URL. So we get everything else, including the expiration timestamp, and store it to the query string variable. The next line is simply hashing the query string using the SHA-256 algorithm to recalculate the signature. Laravel is using the app's encryption key here as the salt of the hashing function, so we can guarantee that the signature is going to be unique. And lastly, we'll compare the calculated signature against the signature from the request query. So if someone tampered with the URL, there's no way that a person can make the hashes equal, unless the hacker is extremely lucky or they're using a supercomputer to brute force the hash. Because if the hacker changes any character in a URL, the hacker will also need to calculate the hash of the new URL that they created. And to calculate the hash, the hacker will need a salt of the algorithm, which is a long-ass string living inside the environmental variable in the server. Under normal circumstances, the server should be very secure, and it's very hard for the hacker to gain access to the environmental variable. And that makes SignRoute in Laravel to have a 5-star rated security level. Alright, that's basically how SignRoute works in Laravel, and now I want a feature in our app that will let our user to share a post privately. Let's go back to web.php, and just for demonstration, I'll create a new route to share a post. And apply the sign middleware on it. And we'll return some text in the response. In the actual app, this route should render the view to display the post, or the API JSON that contains the body of the post. And to share the post, we need a new endpoint to create the signed route. Let's add a new route to our post endpoints. I'll define a new post route in our post route definition file. And this endpoint should trigger a function in a post controller. I'll call it share. Once we're done, let's go to our post controller and create this new function. Within the function body, we'll need to generate the URL. So we'll call the URL facade and call the temporary sign route function. The name of the route will be the get route that I just created a minute ago. That will send back the body of the post that we want to share. And I'll keep this link alive for 30 days. And for the URL parameter, I'll simply set post to the post that the author wanted to share. Once we got the URL, we should send it back as a JSON response. Last but not least, we should also set the documentation for our share function. And now to test our share endpoint in Postman, I'll temporarily disable the auth middleware, because the share route is protected by Sanctum and Fortify, and I'm too lazy to log in and set the CSRF token in Postman. Alright, let's go to Postman, and I'll send a post request to our share post endpoint. And we get a JSON response with the signed URL. Let's click on it, and in our browser, we see the post that is specially made just for you. Alright, key takeaway for this lesson. We can use signed routes to protect our routes from unwanted modification. This is extremely useful for apps that shares protected resources like videos or files. We use the temporary signed routes function in a URL facade to create a link with expiration, while the signed route function to create a permanent protected link. Laravel uses salted SHA-256 algorithm to hash the route as a measure to counter modification in the signed routes. That's it for now, and I'll see you again in the next video. Hey there, Sam! Notification exists everywhere in today's web app. If you're using a social media like Facebook or Instagram, whenever someone commented on your post or give your post a like, you would have received a notification in some ways, either through the bell icon in the app or through an email that was sent directly to your inbox. Laravel makes it easy for you to send notification to your users in the form of email, in-app notification, SMS, or even Slack. And now let's dive into the code right away. To get started with notification in Laravel, we first need to create a notification class. And to do that, we can make use of the artisan command. So let's go to our terminal and we'll type in php artisan make notification and type in the notification name. I want to send our users a notification after they have shared their post, so I'll call it post shared notification. And now let's go back to our project directory, and inside the app folder, you'll notice that Laravel has just created a new folder called notification, and inside it is our newly created post shared notification. Let's click on it, and it turns out that it's just a normal PHP class that extends the base notification class. Let's look at what's inside here. We have a queuable trait, a constructor, a via method, a toMail method, and a toArray method. It looks a bit scary, but it's okay. We'll go through them one by one. First of all, let's talk about the queuable trait. So Laravel allows us to send out notification asynchronously. That means to send out a notification at a later time, rather than immediately. You see, sending out notification is an expensive process. It is not something that can be done within a few milliseconds, especially when we want to send out a notification in the form of an email. It will take up to a few seconds for the process to complete. So if we send out our notification synchronously, it might cause a blocking in our script, and our app will not have a good user experience because our user has to wait for a few seconds before moving on. It's much better to perform this time-consuming task at a later time where the server is not that busy, or to delegate this task to an entirely new PHP worker. And that's exactly what queuing means. Queuing is rather difficult to implement, but thankfully Laravel provided us this helper trait called queuable, where it contains all the helper methods for queuing to work. In order for queuing to work, it's not as simple as loading the queuable trait. We also need to implement the shouldQueue interface on our notification class and also set up a queue driver for our app. Queuing deserves its own video series, and we'll discuss more about it in the future. Okay, next we have the via method, and this is where we define the delivery channels that we want to send out this notification. Laravel provided us a few delivery channels out of the box, including mail, database, broadcast, Vonage, and Slack. The mail channel will send out an email to the user. The database channel would log the notification inside our local database, and the user will be able to view the notification in the front end. The broadcast channel will send out notification to our JavaScript front end in real time through WebSockets. We'll dive deeper into WebSockets in Laravel in the next few videos. Vonage is a web service that will send out SMS messages to our users. And Slack is the popular messaging platform for workspaces. There are other notification drivers like Discord, Telegram, or Microsoft Teams that are actively maintained by Laravel's community. The link is in the description if you're interested. In this lesson, I'll be using the mail driver for demonstration. The via method also accepts a notifiable instance, which will be the user that will be sending out this notification to. The toMail method should return a mail instance class, which is a representation of the email that will be sent out if we're using the mail driver. And here in the starter code, Laravel is using a mail message class instance to quickly build a one-off email. We could create our own mail class and load it in here. And again, the toMail class accepts a notifiable instance where we can use it inside the mail body if we want. The toArray method is used when we're using the database or broadcast driver. Whatever is returned in this method will be used as a payload to store inside the database as a JSON or as the broadcast WebSocket body. Since we are not using the database driver or the broadcast driver, we do not need to touch this method. Again, if you want to learn more about the database driver, feel free to visit the documentation. Okay, now let's edit our toMail function so it is more useful to our user. I'll add a subject where I'll say post shared, and I would like to include the post title here. Let's make our notification class accept the post that we want to share and also the associated signed link. And I'll make these two arguments a private property inside this class. Now back inside our toMail function, I can now pass in our post title to the subject line. I'll keep our mail message simple, so in the mail body, I'll just put in a button and say view the post here and chuck the signed link in there. And that should do the trick. And now let's explore on how we can send out a notification in Laravel. Let's go to the share post controller function that we created in the last video. There are two ways to send out a notification in Laravel. One is to use the notification facade. Two is to call the notify function on the user instance. But before we go any further, we first need to make our user model notifiable by putting in the notifiable trait inside our user model, which should just be there by default. If you don't see the notifiable trait on your user model, make sure to load it, otherwise notification will not work on our user model. You can make any of your other model notifiable by simply putting in this trait. Alright, let's go back to our share method. And now let's use the notification facade to send the notification to our user. The send function accepts two arguments. The first argument is an array of user models. We don't have any users here inside this function scope, so let's do a query on our user model. I'll assume that our request body contains an array of user IDs where there are the users that we want to share this notification to. To get an array of users based from these user IDs, we'll go ahead and call the wherein method on the user query. That will retrieve all the user records based on the provided user IDs from the request. Once we got our users, we can simply pass it to the send function in the notification facade. The second argument will be an instance of a notification, which in our case here will be our post shared notification. The first argument in the constructor will be a post instance, and the second argument will be the signed URL. And that's it, we're done. Let's test our code. I'll disable the authentication middleware again in our API endpoint because I'm too lazy to log in and configure the cookies in my HTTP client. Alright, let's test our endpoint. I'm using Insomnia, which is another HTTP client, because for some reason, Postman refused to work in my computer today. Anyway, I'm sending a post request to the share post endpoint here, and I want to share post ID 1 to user ID 2 and 3 in a JSON body. Let's send a request. And as you can see, it's taking quite a few seconds to send out the notifications because we're using the mail driver. In the actual app, we should be using Q to send out the notifications. Alright, let's go to mailtrap.io and we see two notifications sent out by our app, and each of them is targeting a different recipient. And one last thing before we end the lesson, we can also call the notify function on a user model instance to send out a notification. This was the second way to send out a notification that I mentioned just now. It will work exactly as the send function on the notification facade, just that now we're sending the notification on a per model basis. Personally, I like to use the notification facade because I think the API is cleaner. And that's it. That's the basic on how you can send out notification via emails in Laravel. As I mentioned earlier, there are other ways for you to send out notifications. Please visit the documentation if you want to find out more. If you want me to make a video on the other notification drivers, do let me know in the comments below. Alright, key takeaways for this lesson. Laravel provides us a variety of drivers to send out notifications to our user. For example, the mail, database, broadcast, Slack, and Vonage drivers. There are many more community-maintained drivers like Telegram, Discord, and etc. We can use the PHP Artisan make notification command to generate the boilerplate to create a new notification class. We can use the send function on the notification facade or the notify function on a notifiable instance to send out notifications. That's it for now, and I'll see you again in the next video. Hey there, Sam! You see, a lot of web apps today have some sort of real-time features integrated with them. For example, when you're chatting with someone in a messaging app, you can see whether they're typing or not, or whether they're online or not. Or even when you're using a collaborative app like Google Docs, you could see the cursor positions of your peers and the text they have added to the document in real time. And now the big question is, what is the voodoo magic that powers these real-time features? Well, to answer this question, let's first consider our options. We could get this to work using HTTP. Let's use a chat app as an example. Let's say we have a person A here, and another person B on the right, and our app server sitting in the middle. Now A wants to send a message to B. So A go ahead and type in something in the Messenger app, and now practically speaking, on B's screen, B should see the status of A as typing. And now one of the many ways to get this to work in HTTP is for A to send a request to the server that would update the state of the current conversation record between A and B in the database. And now in order for B to get the latest status update of the current conversation, B needs to send in a HTTP request to the server once every few seconds to get the latest update on a conversation. Otherwise, there's no other way for B to check if A is typing or not. This method used by B is called polling, and it is far from being efficient. Why? Well, because HTTP is rather slow for real-time communication. Depending on the location of the app server and also the associated logic in the API endpoint, a HTTP request could take up to a few hundred milliseconds or even a few seconds in some cases. This delay is certainly not suitable for a real-time app. Secondly, HTTP request is rather heavy. Every HTTP request contains a header and also a body. And other than a request body, the HTTP request also contains cookies and also other metadata about the request. And the same goes with the HTTP response sent back by the server. In a real-time app, there'll be a lot of messages coming back and forth between the client and also the server. If we're using HTTP to facilitate the real-time communication, someone's gotta pay for the bandwidth overhead associated with these HTTP requests. And trust me, it won't be cheap. So what's a better solution then to create a real-time app in contrast to HTTP? And this is exactly where WebSockets comes into the picture. We needed something that's fast, that's lightweight, and supported by the browser. And WebSocket ticks all of these boxes. But before we go on any further, let's first understand what is WebSocket. Well, WebSocket is another way for computers to talk to each other. And just like HTTP, we can use WebSocket to send and receive data from a web server. However, the main difference between WebSocket and HTTP is that in WebSocket, the connection between a client and a server is persisted and maintained, while in HTTP, the connection ends as soon as the server sends back a HTTP response. Now, the persisted connection in WebSocket gives it a huge advantage in building a real-time app. Because now, if the client or the server wants to send each other a message, they don't need to start a new connection, but instead they can just send the message through the existing connection. There's no need to re-establish the connection and go through the authentication processes again. We only need to do it for one time when we first establish the connection. And that is the reason on why WebSocket is much faster than HTTP when transmitting messages. Now, there are two common patterns when building app with WebSockets. The first one is what we call the pub-sub pattern or publisher-subscriber pattern. In a pub-sub pattern, there's always one publisher and a lot of subscribers. The server is usually the publisher, and there'll be a lot of clients subscribed to this publisher. When the server wants to send out or publish a message, the message will be sent out to all of the subscribers. This is a one-way communication method where the server can only send out data and the client can only receive. You can see the pub-sub patterns in a lot of financial apps where they are streaming real-time financial data on a price chart or a candlestick chart. The pub-sub pattern can also be used to stream live video data, where all the clients will receive streaming data from the camera on the server. So if you want to build a video streaming platform like Twitch.tv or a monitoring service like a CCTV system for your home, you might want to consider pub-sub when designing your app. The second common pattern is something called RPC, which stands for Remote Procedure Call. In contrast to the pub-sub pattern, which can only send data in one way, RPC is a two-way communication protocol, and it is very similar to HTTP, except the fact that we're using WebSocket and a connection between the client and server is maintained. So here's how it works. First of all, the client will establish a connection with the server. Once the connection is opened and persisted, the client will send a request through the connection to the server. The server will receive the request and process the request by running some logic on the server side and send back a reply to the client. This is very much similar to HTTP request and response, where the client and server are exchanging data. The request in RPC could contain a body, where it contains all the data needed by the server to run the process on the server side. And similarly, the reply sent back by the server could also contain a body to be used by the client later on. Once the client receives a reply, the client could go ahead and read the body of the reply and proceed to do some other processing. And if needed, the client could send another request to the server through the WebSocket connection. And the process repeats itself. And by looking at how RPC works, we can kind of understand why is it called Remote Procedure Call. Procedure is another name for functions. And here we're really executing a remote functions on the server by sending out a request to the server. And the server will go ahead and send back the result of the function in the form of reply. And as I mentioned just now, RPC is a two-way communication protocol. The client can send data to the server through request, and the server can send back data through reply. However, due to the nature of RPC, the data transmitted in this WebSocket connection can only happen with one client only, in contrast to PubSub, where the data is sent out to multiple clients at the same time. A typical application that uses RPC is a chat messaging app. In fact, in a chat app, it could be a combination of RPC and PubSub working together. Here's one of the many strategies that you could use to build a chat app. Let's say we are in a chat group. There's one server and 4 users. Now Alice wants to send a message to her friends. What Alice could do is to make an RPC connection to the server and send a request to ask the server to record her message in a chat group. Once the server has saved the message, the server would then broadcast the message to everyone else in the room using the PubSub pattern. If someone else in the room wanted to send a message to the group, then they'll make another RPC connection to the server and the process repeats. Isn't that neat? Using WebSockets in your app in the right place could really make your app runs faster than Usain Bolt. But it doesn't mean that you should use WebSocket for everything from now on. WebSocket has its own overhead and it could be quite complicated to set up a proper WebSocket server. Regardless, WebSocket is a promising technology that can really improve your user experience by bringing in real-time features to your web app. Alright, key takeaways for this lesson. WebSocket is a communication protocol to transmit data between computers, where it's commonly used in real-time applications. In contrast to HTTP, WebSocket persists and maintains its connection with the server, so the subsequent data transmission between the server and the client will be lightning fast. And that makes WebSocket an ideal candidate to transmit data in a real-time application. There are 2 common WebSocket app patterns, PubSub and RPC, which stands for Publisher Subscriber and Remote Procedural Call, respectively. PubSub involves one server that broadcasts messages to multiple clients. It is commonly seen in financial apps where there's a need to stream real-time price data. RPC is very similar to HTTP, where the client will send a request and expect a reply from the server. RPC can be used in messaging app. That's it for now, and I'll see you again in the next video. Hey there, it's Sam. Laravel makes it quite easy for us to create real-time app. It has built-in support for PubSub pattern for WebSocket. And just a quick recap, the PubSub pattern is where there's one WebSocket server publishing data to multiple clients. So, in order for the PubSub pattern to work, we need to configure a WebSocket server in our Laravel app. And thankfully, we didn't need to start from scratch. Laravel provided us a few options for our WebSocket server. The first option is to use something called Pusher as our WebSocket server. Pusher is essentially a subscription-based web service that will provide us our WebSocket server once we sign up with them. It is very easy to use and Laravel is fully integrated with it. We just need to write the configuration in a few lines of code and that's it. Our WebSocket server will be up and running since day 1. But the only thing is we need to pay them for every single month. They do provide us a free plan, but with limitations. Now the second option is another web service called Ably. Ably is a competitor of Pusher and it is also a subscription-based WebSocket server. They offer a very similar pricing compared to Pusher and also fully integrated with Laravel. But if you're like me, who has no money to pay for these services and my coffee, we might want to consider some open source options where we have full control and no limitations. Alright, the first open source alternative is Laravel WebSockets. This is a WebSocket server written in PHP, provided by Beyond Code and Sparty, 2 of the biggest open source contributors in Laravel's community. Laravel WebSocket is available as a composer package and it fits in perfectly in our app. There are 2 other open source options, Laravel Echo Server and Sockety. However, they are written in Node, so you'll need to install Node.js before using them. The other thing about Node is that we couldn't run PHP code in these 2 packages. That means we can't extend and modify those 2 packages at the time when we need it. So these 2 options might be less appealing compared to Laravel WebSocket. Our final decision is very clear, we'll be using Laravel WebSocket. Now for the client, Laravel provided us an official package called Laravel Echo, which is a JavaScript npm package meant to be run on all the WebSocket subscribers. We will discuss more about Echo in the next few videos. For now, we'll be focusing on the server side. Alright, let's dive into the code and get started right away. There is quite a bit of configuration that we needed to do to get our WebSocket server up and running. Alright, first of all, let's install Laravel WebSocket. We'll go to our terminal and type in composer require beyond code Laravel WebSocket. The installation note is in the package documentation. The link is in the description. Once we have installed the package, we'll need to publish its configuration. So we'll go ahead and type in PHP Artisan vendor publish and look for Laravel WebSocket in a list. Seems like number 2 is the one. Let's type in number 2. And there you go. We have just copied the migration files and the configuration files to our app. And then we'll run PHP Artisan migrate to create all the tables needed by Laravel WebSocket. Alright, now let's take a look at the package config file. The first option here allows us to set a port to the package dashboard. The package does provide us a debugging dashboard out of the box for us to see any incoming and outgoing WebSocket connections. Don't worry about it for now, I'll be showing you around later on. The next option here is for us to set our app's information that we want to connect with this WebSocket server. Some people might want to set up a WebSocket server for multiple apps in one go, and this is a place for you to define all the informations about your apps. And this is referred to as the source code multi-tenancy architecture. And the next option, app provider, is simply a helper class for us to resolve the correct app for our tenants. You can pass in your custom provider class if you have a much more complicated logic. Allowed origins is where we define all the addresses that we were allowed to connect to our WebSocket server. Any addresses that's not listed here will be banned from connecting to the WebSocket server. Max request size is the size of the payload that's allowed to contain in a WebSocket request. Path is the URI to visit the WebSocket dashboard that I mentioned just now. The middleware listed in the middleware array will be applied to every request visiting the dashboard. The statistics section is where you configure on how we want the package to collect data. Each of the fields listed here has its own documentation in this file. You can have a read if you want to customize the logic. The SSL section is where we put in the configuration if we want to get our WebSocket server to use SSL certificate. You will need this when you want to encrypt the messages transmitted by your WebSocket server. And lastly, we have a channel manager option, and this will be the class that contains the logic to maintain all the WebSocket connections on this server. By default, Laravel WebSocket stores all the connections in a PHP array. If you want to store the WebSocket connection details in somewhere else, like in a MySQL database, then you'll need to write your own manager class. Now, Laravel WebSocket is used as a pusher replacement, and that means we can still pretend that we're still using pusher. And we need to install all the dependencies required by pusher, in particular the pusher PHP server. So in our terminal, I'll type in composer require pusher PHP server. Once that's installed, we'll go ahead and configure our environment variable for the package to work. Let's go to our .env file, and we'll go ahead and change our broadcast driver to pusher. And we'll pass some dummy values to the pusher app ID and pusher app key and secret environmental variables. If you're using pusher, these will be your API keys and secrets for authentication. Since Laravel WebSocket is a drop-in replacement for pusher, we are not using these values for authentication. Instead, Laravel WebSocket will use these values in its configuration to identify the app tenancy, just in case there are multiple apps connecting to the same WebSocket server at the same time. Okay, let's move on. Next, we'll need to set up a queue driver. As I mentioned before, Laravel is implementing the pub sub pattern, and the whole real-time architecture is driven by event. The very same event that we have in our app folder. Whenever there's a new event fired in our app, we could choose to whether broadcast this event or not. If we choose to broadcast the event, Laravel will then send the event to the WebSocket server, and the WebSocket server will broadcast the event to its client. However, the process of sending the event to the WebSocket server is rather time-consuming. It is much more efficient to do the job later. So what we can do is to send this job to a queue system, and we'll process the queue later on when the server is less busy. And that is how Laravel handle event broadcasting in a real-time app. Laravel provided us a few queue drivers out of the box. Typically, we would use Redis as the queue driver, but just for demonstration, I'll be using the sync driver for now. The sync driver, as its name suggests, will process the job synchronously, so there's no queue system at all. If we are using the sync driver, Laravel will send the job to the WebSocket server directly without listing them in a queue. Anyway, to set up the queue driver, we will go back to the .env file and set the queue connection key to sync, which should be the default value out of the box. You can take a look at the other possible drivers in the queue configuration file. There are other queue drivers like Database, Beanstalk, and Amazon SQS on our disposal. And now once we have set up our queue driver, we need to go to our app configuration file and enable our broadcast service provider. Otherwise, we'll not be able to broadcast our event through WebSocket. Alright, now we're ready to see if our WebSocket server is ready to run or not. We'll go to our terminal. Laravel WebSocket actually provided us a nice PHP Artisan command to start our WebSocket server. If you type in PHP Artisan, you can actually see that we have a few new commands. Let's type in PHP Artisan WebSocket serve to start a WebSocket server, and we'll visit the WebSocket debugging dashboard to test if our bad boy is running or not. So let's go to our browser and visit the URL as defined in the WebSocket configuration file, which by default will be Laravel WebSocket. And you should see a web page similar to this. Let's click on the connect button, and if you're able to see this dashboard, that means you have set up everything correctly. If not, seek help. It's a good time to stop here. We'll continue in the next lesson. Alright, key takeaways for this lesson. Pusher, Ably, Laravel WebSockets, Sockety, and Laravel Echo Server are WebSocket servers that are supported by Laravel. Laravel WebSockets is a wonderful open source drop-in replacement for Pusher. Laravel uses the PubSub WebSocket pattern to publish real-time app events. We need to set up a queue driver for Laravel to broadcast WebSocket events. The broadcast service provider should be enabled in the app config, otherwise Laravel cannot broadcast real-time WebSocket events. Laravel WebSockets exposed a debugging dashboard for our WebSocket connections. That's it for now, and I'll see you again in the next video. Hey there, it's Sam. In the previous lesson, I mentioned that every app event is broadcastable to the WebSocket clients. Let's discuss further on this topic. In short, when we want to broadcast our app event, Laravel requires us to broadcast these events through something called channels. There are three types of channels in Laravel: the public channel, presence channel, and private channels. When WebSocket clients want to connect to our server, they'll need to subscribe through one of these channels provided by the WebSocket server. Here's how they work. A public channel does not need authentication, and anyone in the world can connect to this channel. Presence channel and private channel requires authorization, and the difference between presence and private is that a presence channel is aware of all the users that are currently connected to the channel. In other words, all the users in the presence channel can see the information of each other. This is perfect for chat room application where the users know who is online, who is offline, who posted this message and that message, so on and so forth. A presence channel is useful when the identity of the user connected to this channel is important to the application. Private channel, on the other hand, is for situation where we don't want the users to know each other, and we simply only want authorized user to connect to this channel. We can use private channel for general purposes. For example, getting all the login user to connect to the same private channel in our app so that we can easily broadcast notification to all of our users. We don't need each user to know each other, so in this case, a private channel will be perfect. Alright, now let's look at how we can broadcast Laravel app events and define broadcast channels. The first thing that we need to do is to go to our app config file and uncomment the broadcast service provider under the application service provider section. The broadcast service provider here is different to the one provided by the core framework listed up here. The purpose of the core broadcast service provider is to set up the necessary code for broadcasting to work in Laravel, while the one down here is for us to set up our app broadcast service logic, like defining the channel authentication routes, setting up the middlewares, and so on. And now if we look inside the service provider, we can see that it is a very simple service provider class containing only 2 lines of code. The routes function from the broadcast facade will register the authentication routes for presence and private channels to work. And line 19 here will register the authentication routes for private and presence channels. That we define inside the channels.php file, leaving inside the routes folder. Let's take a look inside it. And as you can see here, this file is pretty similar to the other routes file that we have in our app. But instead of using the route facade, we're using the broadcast facade here. and we're defining a channel this time, not a route endpoint. The syntax is pretty similar to its route counterpart. So the first argument is the channel name, and the second argument is a callback function that will determine whether the current authenticated user can subscribe to a given channel or not. The first argument in the callback function is the instance of the current login user, and any subsequent argument represents the value of the placeholders in the channel name. So in the sample snippet here, it is representing the ID placeholder in the channel name. For a private channel, we'll need to return a condition, and if the condition is true, that means the current authenticated user will be able to subscribe to this channel. In a presence channel, however, in order for us to authenticate a user, we need to return the user information in the callback function, rather than just returning a boolean. We will discuss more about this in the next video, where we'll look at how to connect our front end to the back end. But here is a simplified overview on how WebSocket authentication works in Laravel. So here's the client, and here's the server. When a client wants to subscribe to a private or presence channel, the client will first send a HTTP request to the server that is directed to the off endpoint in Laravel, which is by default /broadcasting/off. Upon receiving the HTTP request, Laravel will then trigger the callback function as we define in the channel.php file. If the callback function returns a truthy result, then the server will return a success response back to the client with the appropriate metadata for the client to establish a successful WebSocket connection with the server in a subsequent request. The data in a HTTP response is mandatory to make this WebSocket connection. Now, if the callback function that we define in the channel.php file is returning a false result, then the server will return an unsuccessful response, and therefore the client cannot establish a WebSocket connection with the server. This initial HTTP request and response is what we call as handshake. Okay, now let's look at how we can set up our event classes to get Laravel to broadcast them to the WebSocket clients. And just for demonstration, I'll be creating a dummy event class. Let's go to our terminal and type in PHP Addison make event, and I'll call it playground event. And now let's go to our newly created event class, and the first thing that we need to do in order to make this class broadcastable is to make it implement the should broadcast interface. Laravel will automatically broadcast any event classes that implements the should broadcast interface. And now if we scroll down a little bit more, we can see that there's a function called broadcast on. This is a function where we define which WebSocket channel that we want to broadcast this event on. And by default, Laravel has made this event to broadcast on a private channel. And now just for demonstration, I'll change it to a public channel instead, which will just be the channel class instead of the private channel class. Now the first argument in the channel constructor is the name of the channel. Now our app could have multiple WebSocket channels, so it's a good idea to have some sort of naming conventions, otherwise our channel names could go out of hand very quickly. Personally, I like to name my channel in this way. First, I'll start with the channel type. In our case here, we are broadcasting on a public channel, so it'll be public. Followed by a dot, the second part will be the resource name, and most of the time it'll be a model name. In our case here, since we're creating a dummy class, so I'll call it playground. You can put as many parts as you want, but for the final part, I always like to use it as the channel number or the channel ID. I'll hard-code it as 1 for now. Channel numbers or channel ID is great to manage WebSocket events. For example, if someone is working on post number 1, you wouldn't want events from post number 2 to affect post number 1, do you? That's gonna cause chaos and never gonna lead to a happy ending. Alright, let's test if our event is working. We first need a way to send out this event, so I'll go to the web.php file, and in the playground dummy endpoint, I'll fire an instance of the playground event. And now we'll go to our terminal and start our WebSocket server by typing in PHP Addison WebSockets serve. Once we're done, let's go to our browser and visit the debugging dashboard provided by Laravel WebSockets. Let's click on the connect button and you should see some events pops up in the event list. And if we go back to our terminal, you should also see some debugging messages inside the terminal. Okay, now we'll attempt to call the playground endpoint to fire an instance of the playground event. Let's click on the send button. Oh no, we see an error. It says pusher error, off key should be a valid app key. Now in the last lesson, I mentioned that Laravel WebSocket is a pusher drop-in replacement. We will need to configure Laravel to use Laravel WebSocket as the WebSocket server rather than using pusher. To do that, we need to go to the broadcasting config, and in the pusher driver, we'll add in a few more options. By putting in the host and port, we can define our own custom WebSocket server address. And since we're not using any SSL certificate, we should set use TLS and encrypted to false. Okay, now let's go back to Postman and try again. And we see a 200 response. Fantastic! Let's go back to the browser and look at the debugging dashboard. And we see a new event popped up in an event list, which is our playground event. And if we go to our terminal, we can see that our event is logged in a console with the event name and the channel name. And as you can see here, the default event name is the fully qualified PHP class name of our playground event. And here's a question. What if I want to use my own custom event name? The answer is super simple. We just need to define another function in our event class. And the function name is called broadcast_as. And we should return the custom function name that we want. I'll call it playground for now. Let's test our code. We'll go back to Postman and set another request. And back in our browser, we can see there's a new event popping up, and now with a custom event name called playground. Great! We can also attach information inside the broadcasted event, where the data attached in the event can be used by the front end. To do that, we'll need to go back to the event class and define a new method called broadcast_with. And whatever we return in this function will be attached as part of the event payload. So here, I'm just gonna return a simple dummy array, and we'll go back to Postman and try to send another request. And now if we go to our terminal, we can see that the latest event contains a payload in the data field, and it is exactly the same as what we put in inside the broadcast_with function. Isn't that neat? So that's a basic intro on broadcasting in Laravel and how to broadcast an event. We'll discuss further in the next lesson about the front end, private channel, and presence channel. I'll see you there. Key takeaways for this lesson. If a WebSocket client wants to subscribe to a WebSocket channel in Laravel, the client will first need to perform a HTTP handshake, in other words, to authenticate the user before establishing a persistent WebSocket connection. Event classes will need to implement the shouldBroadcast interface before Laravel can broadcast them to the WebSocket. We'll need to configure the host and port of the pusher driver in broadcasting.php config file to get Laravel to use our self-hosted Laravel WebSocket server. Otherwise, Laravel will attempt to use pusher out of the box. By default, Laravel will use the event fully qualified class name as the event name. If we want to use our own custom event name, we need to define the broadcast_as function inside the class. We can attach data inside the event payload by defining a broadcast_with functions inside the event class. That's it for now, and I'll see you again in the next video. Hey there, Sam. Let's learn how we can subscribe to a WebSocket channel on the front-end JavaScript. Thankfully, Laravel has provided us a client library called Laravel API that takes care of all the hard work for us, so we can easily subscribe to our channel and listen to events. So first thing first, let's go to our terminal and run npm install Laravel API. We will also need to install the client library of pusher.js because we're using the Laravel WebSocket server as a proxy to the actual pusher server. And now once we have installed the npm packages, we'll need to configure Webpack in order for us to use these packages in our front-end JavaScript. And thankfully, Laravel provided us a tool called Laravel Mix, which is a wrapper around Webpack to let us configure Webpack with an easy-to-use API. To configure Laravel Mix, we need to go to the file webpack.mix.js, which is living in the root of our project directory. Now, if you're not building the front end, this part might not be that relevant to you. We are really just compiling all of our front-end code for our app. Now, I want to enable the hot module reload feature in Webpack. So what I need to do in this file is to call the option function from Laravel Mix and pass in the option, where I'll define the host and the port for the hot reload development server. The hot reload development server will serve as a proxy server to store all the compiled assets. And once we're done, we will create a new blade file for our WebSocket experimentations. And I'll go ahead and load our JavaScript where the source URL is in our hot reload server. Laravel Mix allows us to resolve the compiled assets in the hot reload server by using the Mix helper functions. And once we're done, we can ensure that the code in our app.js will become available to this blade file. Alright, let's take a look inside our app.js. It is quite empty, and the only line is loading the bootstrap.js file. And bootstrap.js is really loading all the global libraries into the Windows object. And at the very bottom of this file, we can see that in the commented code here, Laravel has provided us some snippets for us to load Laravel Echo. Let's uncomment it, and what it is really doing here is to load Echo and Pusher into the Windows object, so that we can call these libraries globally in our app. Let's take a brief look at the configuration of Echo. The broadcaster option is for us to define the broadcast driver, which in our case will still be Pusher since we're using Laravel WebSockets. Key is the API key of Pusher, and we're simply reading it from the .env file. Laravel Mix will automatically load all the env variables with the mix prefix. Cluster is the cluster information about the WebSocket server. We don't really need it in our case because we're not using Pusher. False TLS is only required when we're using SSL. We will set it to false for now. And on top of this existing configuration, we also need to pass in a few more for Echo to work correctly. The first one is the WS host key, which is a host name of our WebSocket server. And in our case, it has the same domain name as our front-end client. We can just use window.location.hostname. And we also need to set the port of the WebSocket server and also set encrypted to false, and again, because we're not using SSL. And finally, to set the enabled transport property so that will restrict the transport of data to the WebSocket protocol only. WSS is a secure version of the WebSocket protocol that utilizes the SSL certificate, just like HTTPS in HTTP. Okay, now we have finished setting up Echo. We are ready to connect to our WebSocket server. Let's go to app.js, and currently we have only one public channel defined on our server from the previous lesson. To subscribe to a public channel, we simply need to call the channel function on the Echo object that we have set on the Windows global object. This function will return us a channel object that contains a multitude of helper functions for us to work with our WebSocket channels. We can call the subscribe function to register a callback that will be triggered when we have successfully connected to a channel. I'll simply console out subscribe just for demonstration. And now let's try to run our app. We'll go to our terminal, start our server, and start the WebSocket server. And we also need to start the hot reload development server. And thankfully Laravel has provided us a script called hot in our package.json. And now the last thing that we need to test our code is to set up an endpoint to serve our WebSocket dummy blade file. I'll simply go to the web.php file and register a new endpoint called WS, which will simply send back the WebSocket view. Okay, now everything is ready. Let's go to our browser and visit our app. And in the browser console, we can see that the callback has been triggered and we are subscribed to the public channel. And just to double check, if we go to our terminal, we can see that in the console, it says that subscription succeeded and there's a new connection subscribed to the public channel. Great! And now let's look at how we can receive events in a front-end client. To do that, we need to call the listen function on the channel object. The first argument is the event name. So in the playground event that we created in the previous lesson, we have made it so that it will be broadcasted under a custom name called playground. Since we have used a custom name, so in the listen function, we need to put a dot prefix before the event name. Otherwise, Laravel Echo will be using the default prefix, which is the fully qualified event namespace in Laravel's app. The second argument that the listen function will receive is a callback function to handle the event. And the argument is the event payload. Just for demonstration, in the function body, I'll console log out the event for now. Let's go back to our browser. I'll hit refresh and go to Postman and send a request to the playground endpoint that we created in the previous lesson to fire the playground event. And in the browser console, we see the event payload printed out in the console, which is exactly the data I have attached inside the playground event that I have defined inside the broadcast with function. Isn't that neat? Can you think of any application that you can build with this feature? Let me know in the comments below. But for now, just as a quick example, we can easily build a simple messaging application using WebSockets. Let's give this a go. First of all, I'll add an input box in our HTML for the user to type in their messages. Next, I'll add an event listener so that whenever the user has entered a message will send an API request to the server, and the server will broadcast an event to the other subscribing clients, and the broadcasted event will contain the text message that the user has just entered. So within the event listener, we'll grab the user input and go ahead and send a post request to an API endpoint, which will be defining it very soon in our API server. Okay, now let's go to our web.php file and we'll quickly define a new endpoint called chat message. This post endpoint should fire an event that will be broadcasted to the WebSocket. I think it's a good idea to refactor our playground event to something more meaningful. I'll refactor the playground event class into chat message event, and this class will accept a string message in the constructor. And I'll rename the channel name to public chat1 instead of public playground1. And I'll also rename the event broadcast name to chat message. And the event payload will only contain one property, which is the message to be broadcasted. And now back inside our app.js, we'll change the subscription channel to public chat1 and also refactor the event name. Alright, let's test our code. We'll go to our browser, type in a message, and oops, the page refreshes because I forgot to call prevent default on the submit event. Let's try again. The page stopped refreshing, but we got nothing in the console. And the reason is because we haven't defined anything in the body of our chat message post endpoint. So let's go back to web.php. We will fire the chat message event in the endpoint and pass the message inside the request into the constructor of the event class. Alright, let's go back to our browser and try for one more time. I'll hit enter in the input box, and this time we see our message appearing in the console. Great! And now if I open a separate browser window and type in 123 in the text box, and we see the message 123 appearing in the first browser window, because both of the browser windows are now subscribing to the same channel, and the message event is broadcasted to all of the subscribers. That's the reason on why the first browser window is receiving the message 123 that I typed in the second browser window. Alright, let's keep going. Now I want to keep a history of all the messages that we have typed in the DOM. Let's see how we can achieve this. I'll go back to the HTML and create a list, and I'll put in all the messages inside this list. And now I'll go back to app.js, and every time we got a new message from the WebSocket, we'll create a new list item and add it to the message list. Okay, let's test our code. I'll type in 123 in the browser window, and the message shows up in the other. Let's try it on the second browser window. I'll type in 222, and it shows up in the first browser window as well. Isn't that great? We got the basic aspect of a chat app working. Now the next thing that we need to do is to make use of the private or presence channel, so that will only allow authorized user to send messages. We'll continue in the next lesson. I'll see you there. Key takeaways for this lesson: Laravel API is the official JavaScript client for us to subscribe and receive WebSocket events from the server. Laravel Mix is a powerful wrapper around Webpack that provides a painless API to configure Webpack. We use the channel function from Echo to subscribe to a WebSocket channel. And the subscribe method lets us to define a callback that will be triggered when we have successfully subscribed to a channel. The listen function allows us to listen to WebSocket events, and we should use a dot prefix when we want to listen to a custom event in Echo. Otherwise, Echo will be prefixing the fully qualified class name of the WebSocket event. That's it for now, and I'll see you again in the next video. Hey there, Sam! Let's look at how we can authorize a user to join a channel. As I mentioned in a few lessons ago, we will need to use either a private channel or a presence channel if we want to implement authorization. Let's start by changing the channel of our chat message event. Currently it's on a public channel, so I'll change the class name to private channel instead, and also refactor our channel name. Next, we'll need to define the authorization logic for our newly created private channel. We'll go to channel.php that lives inside the routes folder, and we'll define the new channel in here. We will call the channel method from the broadcast facade, and the first argument will be our channel name, which will be private chat and an ID. The second argument is a callback function that takes in the current login user as the first argument. And the second argument is the ID placeholder that we have in our channel name. And in the callback function, we'll return a condition where it will determine if the user is allowed to join the channel or not. For now, I'll just return true just for demonstration. And that means to always let the current login user join our channel without any extra conditions. Now also note that if our website visitor is not logged into our app, they cannot join a private channel. By default, if someone wants to join a private or presence channel, Laravel will authenticate them using the default authentication guard, which was defined in an auth config file. And if you want to have a final control on a per channel level, you could pass in a third argument in a channel function where you define the guards that you want to apply to authenticate the user. But 90% of the time, you don't really need to touch this option. Anyway, let's test our code. We'll go back to our app.js and subscribe to the private channel instead of the public channel. Now instead of calling the channel method, we should call the private method to connect to a private channel. And now we'll go to our browser and we see a 403 error coming from a post request sending to the broadcasting auth endpoint. This is the HTTP handshake that I mentioned in the previous lessons. So the client attempted to establish a connection with the server but got rejected by the server because we're not logged in, because of the default authentication guards that Laravel has attached to the channel. To fix this error, we first need to log in before we subscribe to the channel. And we'll copy and paste the login logic that we have created in several episodes ago from the app.blade file. And then we'll move our channel subscription logic after we have logged in. And now let's go to our browser, hit refresh, and we no longer see errors. And that means we have successfully subscribed to the private channel. And now let's see what will happen if we return false in the authorization callback function. Let's go back to our browser, hit refresh, and we see the 403 error again on the broadcasting auth endpoint. And that means the handshake is rejected. We definitely don't want that, so let's change it back to true. Alright, let's move on. I would like to display the author of each message in the DOM as well. And that means every time when we emit the chat message event, we should also attach the current login user in the event. So let's go to our chat message post endpoint and we'll pass in an instance of the current login user to the event constructor. And within the event class, we'll set the user as a class property and attach the user in the event payload. We don't want to attach every information about a user inside the event payload, so we'll just put in the name and email field. Okay, now let's test our code. Let's go back to the browser and send a message. And in the console, the event payload that we received contains the user email and name. And we can certainly make use of the information inside the event payload to make our UI better. Let's do that. And I'm going to turn on my 10x speed boost life hack to code faster. I would also like to put in all the people who are online in this chat room in the nav bar. I'll put in some placeholder avatar for now. And there we go. We've got a nicely styled template to work on now. We just need to populate the data into our DOM. First of all, let's clear our hard-coded data and we will modify our list item creation in JavaScript. I'll copy one of the hard-coded block and paste it inside our app.js as a reference. And I'll go ahead and replicate the structure in JavaScript. And we'll go to our browser and test it. And it works. And now I'll open a new browser window and test if it is working as expected. And it works great. And now the next thing that we need to do is to put all the online users on the navbar. And that means we need to keep track on who's entering the channel and who's exiting the channel. Unfortunately, this is not something that a private channel can easily achieve. So instead, we need to use a presence channel. And just a quick recap, the difference between a private channel and a presence channel is that a presence channel is aware of all the users that's currently in the channel. I'll show you what I mean. First of all, let's change the channel that the chat message event will broadcast to a new presence channel. And I'll go to channel.php and refactor the authorization logic. In a private channel, we need to return a boolean in the authorization callback function. However, in a presence channel, we will need to return the authorized user. So if we decide to let the login user to join the channel, we should return the user instance. Otherwise, we don't need to return anything in the callback function. And now let's go to our app.js. To subscribe to a presence channel, we'll need to call the join method on echo instead of the private function. And now we'll have access to a few more API. In a presence channel, the function to define the onSubscribe hook is called here instead of subscribed. And the callback function accepts an argument which represents an array of all the users who are currently in the channel. So later on, we'll be populating every one of these users into our navbar. We also have another method called joining, which will be triggered whenever there's a new user join the channel. And also a leaving method, which will be called when a user leaves the channel. Alright, let's give this bad boy a test run. And upon reloading our browser, we can see that the user array is printed out when we subscribe to the channel. But when I refresh the second browser window, we are not seeing the joining method being called. And that's because currently we're logged in as the same user. I'll quickly make a login form so we can log in as other users. Alright, our form is ready. I'll log in as the first user and the second user in a private window. Alright, as you can see, as the second user logged in, the console is printing out the newly joined user information, which is what we return in a channels.php callback function. And now, if user number 2 tries to exit the chat room, we'll see the leaving callback function got triggered as well. So that means our presence channel callbacks are registered correctly. And now, let's polish our code so that we'll show all the online users in a navbar. I'll create an empty array to store all the online users, and when the here function is called, I'll reset this array to be the users currently in a channel. And I'll also create the helper function called render avatars, which will simply loop through all the users online and generate an avatar for each of them, and append it into the navbar. Let's give this a go. And it's working, but I forgot to put in the initials inside the avatar. I'll create a helper function to retrieve the user initials. And put the initials within the avatar. Let's try again. And it's working great. And now let's write the logic for the leaving and joining callbacks. So when a user has joined the channel, we will add the user to our users online array and re-render the avatars. And when a user is leaving the channel, we will filter out the user from the users online array and again re-render the avatars. Alright, let's run this bad boy for another time. We'll log in the first user and the second user. And we see both users' initials are popping up in the navbar. Great! And we'll send a message on behalf of each user. And they are showing correctly in the chat box. Wonderful! And now if the second user is leaving, the user's avatar in the navbar disappears. Great! Our app is working as we expected. And one last thing, I would like to show a divider whenever someone joins the room or exits the room. Let's refactor our code. I'll create a helper function to generate a new text box in the app. And the function body is pretty much what we have done in the event listener for the chat message event. So I'll cut and paste it and modify it accordingly. now when a user joins or leaves the channel, I would also like to add a new chat message to notify everyone in the room about it. Alright, let's test our code. We'll log in as the first user and second user in the private window. And upon logging in, we see the message the second user has joined the room in our first browser window. And when the second user leaves the room, we see the message has left the room. Isn't that neat? And now we're still lacking of one feature, which is typical in a chat room. That is, whenever someone is typing a message, I would like to show a typing notification to everyone in the room. We'll talk more about this in the next lesson. Key takeaways for this lesson. Private and presence channel will only allow authenticated user to join in. They uses the default auth guard to authenticate users. Presence channel keeps tracks of all the subscribing clients, while private channel doesn't. We use the private function in echo to subscribe to private channel and the join function for presence channel. We need to define an authorization callback in channels.php for private and presence channel. The private channel auth callback should return a boolean, while the presence should return the authenticated user instance. That's it for now, and I'll see you again in the next video. Hey there, Sam. HTTP is rather slow compared to WebSocket, and in a real-time app, speed is the utmost priority. So if you want to get more juice out of our app, we should make good use of WebSocket. Currently, our chat app is not perfect. Here's what has been happening behind the scene. This is our client number 1, and this is our server. So client 1 wants to send a message to the group chat, and it will do so by sending in a HTTP request to the server. The server receives the request and proceed to send out an event. Then the event will be broadcasted through the WebSocket server to client 2. Now as we know, HTTP request is slow. It could cause some delay for the event to arrive in client 2 and will be the bottleneck for this WebSocket architecture. And things get even worse if we are using an asynchronous queue driver to broadcast the event, which will cause further delay in the whole process. Now the point here is that if there are events that we don't need to pass through the Laravel server, we could have established a connection directly with the WebSocket server and transmit the data to our peers without going through our Laravel app at all. By using this path, we can transmit data to the peers in a near real-time speed. And now the big question is, how are we supposed to achieve this? Well, there are two ways that I can think of right now. One is a long way, which is more powerful, but at the same time more complicated. That is to set up a WebSocket RPC API on our WebSocket server. The second way is a shorter and easier way, which is to use a built-in Laravel echo function called Whisper. That will allow WebSocket clients to talk to each other without going through our Laravel server. We'll discuss the short way in this lesson and the long way in the next video. Okay, now I want to implement the someone is typing feature in our chat room. So the idea here is that if someone started to type something in the chat box, we will broadcast the event to everyone else in the channel. Alright, let's get into it. So here in our app.js, I'll add an event listener to the input message box. So for every keystroke, I will whisper or broadcast a typing event to everyone in the channel. The whisper function accepts two arguments. The first argument is the event name and the second argument is the event payload. And I'll just put in the user email here. And now to listen to the incoming whisper messages, we will need to call the listen for whisper function on the channel. And upon receiving the typing event, I would like to show a small display in the DOM to notify everyone in the room. Let's go to our HTML and do exactly that. I'll add a span just above our input element, back to app.js, target the element. And when someone's typing, I'll simply set the text content of the span to the email in the event payload and adding a text is typing at the end of it. And now before we test our code, we need to make sure that in our WebSocket config, we have enabled the client messages option. And remember to restart your WebSocket server after that. Okay, now let's go to our browser and test our code. I'll log in as two different users in two browser windows. And now if I type in something in one window, the other window shows the typing notification. Great! And now here's another problem. When I clear the content in the input box, the typing notification still exists in the other window. And it is also a good idea to leave a small spacing on the left hand side of the notification. Let's fix these two things quickly. I'll add a small padding left on the span. And in the input event listener, when the value in the text box has a length of 0, that means the user has cleared everything in the text box. We'll whisper a new event called stop typing. And back to our channel listen chain, I'll listen for the stop typing event, where we'll set the spam typing to empty when the user has stopped typing. Alright, let's test our code. Okay, as you can see, as I clear out my text message, the typing notification disappears. And that's how the whisper function works in Laravel Echo. Alright, key takeaways for this lesson. HTTP is rather slow for real-time application. It is quicker to communicate with the server through WebSocket connections. The whisper function from Laravel Echo allows us to send events to each other without passing through Laravel. The listen to whisper functions listen to peers event in a channel. That's it for now, and I'll see you again in the next lesson. Hey there, it's Sam. HTTP is rather slow, and in some real-time app, the delay in processing HTTP requests could be the bottleneck of the whole application. So, what's the alternative then? The answer is something called RPC. And just for a quick recap, RPC or Remote Procedural Call is a WebSocket pattern that is pretty similar to HTTP. So the WebSocket client will send a request to the server to execute a function in the server, and the server will send back a reply which contains the result of the functions. Since we're executing a remote function in the server, and that's why it's called Remote Procedural Call. Unfortunately, Laravel does not support RPC by default. The WebSocket architecture that Laravel utilizes is the pub/sub pattern, not the RPC. To implement the RPC pattern, one has to have the full control on the WebSocket server. And thankfully for us, since we're building the WebSocket server by using Laravel WebSocket, we have full control on the server, and therefore it's possible for us to implement the RPC pattern. And furthermore, Laravel WebSocket is written in PHP, therefore it means that we can access to all the Laravel components in the WebSocket server. If you're using a WebSocket server that's based on other languages, then you might need to build your own custom bridge to connect the WebSocket server to Laravel. Okay, now let's take a look at how we can implement the RPC pattern using Laravel WebSocket. If we go to its documentation, on the left hand side, there's a section called Custom WebSocket Handlers. And that is exactly what we need to implement RPC. In short, we can define these WebSocket handlers to directly accept WebSocket requests in Laravel. All we need to do is to create a handler class that implements the message component interface. The class contains a list of WebSocket lifecycle methods for us to customize the WebSocket logic on different stages of the WebSocket connection. Once we have defined a handler, we simply need to go to the web.php file and register the handler to a WebSocket route, which is very similar to how we define a HTTP request endpoint using a controller class. Let's create one of these handler files in our project. I'll create a new folder called WebSockets in the app folder and a subfolder called Socket Handler. And we'll create a new class here called UpdatePostSocketHandler, where the main purpose is to update a post. And just like what the documentation has said, the socket handler should implement the message component interface. Now the message component interface has 4 methods. The onOpen method will be called upon establishing the WebSocket connection. OnClose will be called when the WebSocket connection is ended, and onError is called when there's an error, and onMessage is called when the WebSocket server receives an incoming request. The first argument contains the details about the connection, and the second argument is an instance of a message interface, where it contains the message body of the incoming WebSocket request. Whoops, seems like I have implemented the wrong interface. It should be the message component interface under the wretched WebSocket namespace. Now every WebSocket handler will need to implement these 4 methods. While the onMessage method could be different from class to class, but the onOpen, onClose, and onError methods should have a very similar logic for all handler classes. And that means we can abstract these 3 methods to a base class. Let's create an abstract class for that. And just for demonstration, I'll just dump a few simple messages on each method. Now for the onMessage method, we will need to write the logic to update a particular post. Let's leave it for now. We will first need to register our handler in our web.php file. We can easily do that by calling the WebSocket function on the WebSocket's router facade. The first argument will be the route name, and the second argument will be the handler class. We'll go to our front-end app.js and attempt to connect to our WebSocket server. I'll create a new function called updatePost, and now we're connecting to our WebSocket server directly, so we're not going to use echo. Instead, we'll be working with the built-in browser WebSocket API. So we'll create a new socket instance and pass in the URL to our WebSocket updatePost endpoint. The socket object has a few properties for us to set a few lifecycle hooks on the WebSocket connection. We'll go ahead and set the onOpen function for now. And when the WebSocket is opened, we'll simply console log out onOpen. And then we'll call this function after we have logged into our app. And I'll comment out everything about echo for now. Okay, let's head to our browser and test our app. We will log in, and we see onOpen in the console. We have successfully established a connection with the RPC WebSocket server. However, now there's a few concerns about the security of our WebSocket endpoint. Currently, our WebSocket route is defined as it is without any middleware applied on it. It has zero protection whatsoever. And that means everyone can connect to this WebSocket endpoint without logging in. I'll show you what I mean. We'll go back to app.js and we'll call our updatePost function outside the login callback function. And we'll go back to our browser and I'll open a new private window, visit our app, and we'll still see onOpen in the console without even logging in. That is a big no-no. We definitely don't want everyone in the world to be able to connect to our precious WebSocket endpoint. How do we fix this? Well, we are using the WebSocket protocol here, so we can't really use HTTP middleware. One of the possible options is for us to define our authentication logic in the onOpen lifecycle hook. We could access the incoming HTTP metadata here by reading the HTTP request property on the connection instance. I'll die and dump it here just to look at what's inside this property, and I'll restart our WebSocket server. And as you can see in the terminal, we can see all of the incoming details about the initial handshake. And we can go ahead and use all the data here to perform our authentication logic for the WebSocket connection. I won't be writing the authentication logic here, otherwise this video will be too long. For now, we'll look at how can we send data to our WebSocket server from our JavaScript client. But there's one thing that I'll do, which is to attempt to read the app key from the incoming connection. So if we look at the default WebSocket handler in the Laravel WebSocket package source code, we notice that in the onOpen function is calling a function called verify app key. Now the verify app key will attempt to read the app key query parameter from the incoming HTTP request and check if it is a legitimate app key from the config file. If not, it will throw an error. Now in our own custom WebSocket handler, we should be consistent with this approach. So we'll copy and paste the verify app key function to our onBase handler and call this function on the onOpen lifecycle hook. And now since our WebSocket server is checking the app key query parameter in the HTTP request, so that means in our app.js, when we want to create a new WebSocket connection, we should also pass in this app key. Let's restart our WebSocket server and go back to our browser, and it's all working. And now let's try to send some message to our server. So in app.js, upon connecting to the WebSocket server, we'll try to send a payload by calling the send function on the socket object. We can only transmit string data or array buffer, so we'll stringify our payload by calling the JSON stringify function. And I'll say the payload contains the ID of the post that we want to update and also a payload property which contains the post attribute that we want to update. I'll hardcode the value for now. And we'll go back to our update post socket handler and I'll dump the message in the onMessage lifecycle hook. The message object provided us a few helper functions, and we can call the getPayload helper method to grab the content of the message. Alright, let's restart the server. And we'll see an error. And it says undefined property socket ID. So it turns out that we need to define a socket ID for each of the incoming WebSocket connection. How do we do that? Let's take a look at the source code of Laravel WebSocket again. In the provided socket handler class, we can see that in the onOpen lifecycle hook, it is calling another method called generateSocketID. In the function body, it is simply generating a random number and set to the connection object. Let's copy and paste this function to our base handler class, and now call this method in the onOpen hook. Alright, let's restart our server again and refresh our browser. And now our server console is no longer printing out an error. Instead, we see our payload inside the console. But it is in the form of a string. To work with this JSON string, we need to convert it into an array in PHP. I'll call the collect and JSON decode function so I can work with the payload using the collection API provided by Laravel. And now we'll retrieve the payload and the ID from the message body. We'll dump the payload and ID variable to check if our code is working correctly. Let's restart our server, visit our browser again, and inside our terminal, and we can see that our payload and ID is dumped in the console exactly as what we have sent in a JavaScript client. Okay, now let's update our post using these two information. We'll first find the existing post in our database, and then we'll call the update function on the repository to update our post based on the payload. Once the post is updated, we will create a response using the post resource class, and we'll send the response back to the client by calling the send function on the connection instance, which is represented by the from variable. And now we'll go back to app.js and add the onMessage hook on our socket to receive the reply coming back from the WebSocket server. Okay, let's restart the server and we'll go back to the browser and refresh the page. And nope, we're not receiving any message coming back from the server. And if we go to our terminal, we can see that our server did receive the request, but for some reason, our app is stuck in between the dump and the send function. Why is this happening? So it turns out that in our post repository, we're sending out a post updated event upon updating our post. Now by firing this event, Laravel will attempt to broadcast it to all the WebSocket client. At the moment, we are using the sync broadcast driver. We are still in the middle of an RPC connection. We can't instruct the server to send out another broadcast. It's like someone who's buying a walking sleeping bag, who wants to sleep and walk at the same time. So the code will stuck here forever. So to rescue this code, we'll have two options. One is to comment out the post updated event so our app will not attempt to broadcast another message while the RPC is still ongoing. The second way is to use an asynchronous queue driver like Redis for our post updated event. Alright, let's restart our server and we'll go back to the browser. And now we see a message event popping up in the console. Great! However, the event data is a raw HTTP response, so it might be better if we call the toJSON function instead of the response method in our update post socket handler. Alright, so that's an overview on how we can implement RPC using Laravel WebSocket. And now you might be asking, does that mean RPC can replace HTTP? And my short answer is yes. But you'll need to make sure that the server has the capacity to handle all the incoming WebSocket connections. Alright, key takeaways for this lesson. RPC or Remote Procedure Call is a WebSocket pattern that works very similarly to HTTP, following a request and reply pattern. HTTP is rather slow. RPC could be a faster alternative for real-time apps. Laravel WebSockets allow us to work with the low-level WebSocket API using WebSocket handlers. Although it is faster, we need to write a fair amount of code to handle security as it is not provided out of the box. That's it for now, and I'll see you again in the next lesson. Hey there Sam! When we deploy our app to the live production environment, it is inevitable for us to configure our WebSocket server to use a SSL certificate for WSS encrypted connection. And it is also probably a good idea to test your development environment with self-signed certificate before you push to the live production environment. Now here, I'm using a Docker environment as an example to show you how I set up the SSL certificate. If you haven't learned about Docker yet, this section might be a little bit confusing to you. But that's okay, just think of Docker as a virtual machine and try to follow along with this tutorial. Let me know in the comments below if you want me to make a Docker tutorial series. I have a few Docker containers here, But what we need to focus now in particular is the Nginx container, which is our main web server, and also the workspace container, which is where I run our WebSocket server. And currently I'm running a shell instance inside the workspace container. And I'll start Laravel WebSocket by typing in php artisan WebSocket serve. To configure the SSL certificate, the first thing that we need to do is to supply the path to our certificate in a .env file. Laravel WebSocket will read these values and attempt to read the certificate and its key when it's trying to set up a secure WebSocket server. So make sure that your app has read access to the certificate that you specify in this path. Otherwise, you'll encounter an error. These values are being read inside the WebSocket config file under the SSL key. And if you're using self-signed SSL certificate, you might want to disable some of the built-in authorization feature like verify peers and verify peer name. Otherwise, you might encounter an error. Next, we need to go to our broadcasting config file, and there's a few things that we need to configure here. In the option key, the host will be the host of your WebSocket server. In my case, it will be the name of my Docker container. If you're using Docker, make sure that you have configured your network correctly. We need to set encrypted to true and also scheme from HTTP to HTTPS, and also set use TLS to true. If you're using self-signed certificate like me, you might also want to put in these two curl options. The reason is the same as before, to disable some of the authorization feature for self-signed SSL to work. And now the last thing that we need to do is to configure Echo. Let's go to bootstrap.js. In addition to WS port, you now also need to set a WSS port. And we want to set encrypted to true and also false TLS to true. And now it's time to test our connection. And if you have edited any of your WebSocket server settings, remember to restart your server. Let's go to our browser and I'll visit our WebSocket dashboard. I am greeted by a warning sign. And that's normal because I'm using a self-signed certificate. Just ignore the warning, it's totally safe. I can guarantee you your safety. And now once we're in the dashboard, let's click on the connect button. And oh dear, we see an error in the console, saying that we could not establish a connection to the WebSocket server. And the error message is not helpful at all. It did not tell us any reason whatsoever. And I've spent several painful hours figuring this one out. So it turns out that it's an issue with self-signed certificate. We have enabled the certificate for our web server just now in our browser, but we have yet to do so for our WebSocket server. So what we need to do here is to visit the WebSocket URL and change the protocol to HTTPS rather than WSS. And we're greeted by another warning page, and by clicking on proceed, we are enabling the certificate for our WebSocket server. Now back to the dashboard, we can now connect to our WebSocket server. Problem solved. If you're using a SSL certificate with a valid authority, you won't be having these problems at all. And that's how you configure SSL in Laravel WebSockets. Alright, key takeaways for this lesson. To configure SSL certificate for Laravel WebSocket, we need to set the certificate path in the .env file. And in the broadcasting.php config file, we will need to set the encrypted option to true and set scheme to HTTPS and set use TLS to true. For Laravel Echo, we will need to set the WSS port and encrypted to true and also false TLS to true. That's it for now, and I'll see you again in the next lesson. If you enjoyed the content of this video, don't forget to hit the like, subscribe and the bell icon for more content to come. It will really help me out. Thanks for your support.